welcome to our review for our first test. This will be the Chapter 10 test, and I'm going to go ahead and solve all of these questions that are in the review. So number one, it says, write each product using exponent. So I have a negative 7 times negative 7 times negative 7. Well, this one is going to be negative 7 to the third power because it's the base. The base times itself 3 times, and that's what the exponent tells us. So number 2 is going to be 5 times 5 times 5 times 5. The other way to write this would be 5 to the 1, 2, 3, 4, 5th. 5 to the 5th. On number 3, it's evaluate, solving using order of operations. So remember that our order of operations are parentheses, exponents, multiplication or division, and then addition or subtraction. So looking at number 3, from left to right, I'm looking for any parentheses, and I do have parentheses. So right here I have 2 to the 5th. So 2 to the 5th is the same as 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So I'm going to rewrite this as 9 minus 32 times a half, 0.5. So now I'm scanning again, left to right. Any parentheses? No. Any exponents? No. Any multiplication or division? Yes. And what I have here is I have 32 times a half. Well, what's half of 32? Half of 32 is 16, so I have 9 minus 16. And 9 minus 16 is a negative 7. So for number 3, my answer would be negative 7. Number 4, same thing. I'm going to be looking any parentheses, and I see parentheses, but there's nothing I can do inside the parentheses. Any exponents? Yes, so I have 4 squared. 4 squared is 16. And then I have minus 8 times 2 plus 3 to the third. So 3 to the third is 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So now I'm looking at this problem again. Any parentheses? No. Any exponents? No. Any multiplication or division? Yes. I have multiplication. So I have 16 minus 8 times 2 is 16 plus 27. 16, take away 16 is 0. 0 plus 27 is 27. So my answer here would be 27. Let me clean this up a little bit. All right. So on number 5, simplify. 2 to the 4th times 2 to the 5th. Well, if the bases are the exact same, the bases, in this case it's a 2, if they're the same and we're using multiplication, then this would be 2 to the 4 plus 5th exponent, which would end up being 2 to the 9th. 2 to the 9th would be my answer for number 5. Number 6, our bases are the same again. When the base is the same, we are simply going to add the exponents. So I would get x to the 3 plus 7th exponent, which in this case is going to be x to the 10th. And that's it for 1 through 6. Number 7, when we have something that is a power raised to a power, here where we have outside of the parentheses this exponent raised to another exponent, we're going to multiply these. So this is going to be 3 to the 4 times 3, which would be 3 to the 12th. Number 8, it's going to be the same rule. It is a product or a power raised to another power, or exponent raised to another exponent. If it's an exponent raised to another exponent, we multiply them. So this is going to be w to the 5 times 4, which would end up being w to the 20th. On number 9, we have a times b to the 5th. This one is kind of like the distributive property. We have to share it to both. And so this would be a to the 5th times b to the 5th. And that's as far as you could simplify it. On number 10, this one we have a negative exponent, and we don't like negative exponents. So we have to figure out how to change this. I'm going to show you two ways. One way is just by the rule that we have. If we have a to the negative n, that changes into 1 over a to the positive n. In other words, you take this whole thing, you move it down underneath 1, and then your exponent changes to a positive. So if we just use that rule, we would have 1 over 4 to the second. The other way that you can think about this is if you had 4 to the negative 2, you could make that a fraction by putting that over 1. And I know we talked about this in class. If it's negative, like here, it's negative, we can send it to its room. And if we send this down to its room, it would become 4 to the second. This is an acceptable answer. If you wanted to take it one more step, you could get 1 over 4 squared, which is 16. And that's 7 through 10. On number 11, you can see that our bases are the same, and we're multiplying. So what we're going to do here is we're going to add these. So if we add these, we would get 6 to the negative 8 plus 8. Well, negative 8 plus 8 is 0, so we get 6 to the 0. And then we have a 0 property rule that tells us anything to the 0 power equals 1. And that makes number 12 really easy, because we have 247 to the 0 power. That's going to equal 1 also. Number 13. Well, we've got negative 7 to the 9th over negative 7 to the 3rd. And one thing that you should remember is that you've got 9 of these negative 7s in the top and 3 in the bottom. So if you canceled, you'd be able to cancel 3 sets, leaving you with negative 7, and you'd have 6 of them remaining in the numerator. So this answer would be acceptable. Another way to think of this is, for a quotient, we have a rule that you just subtract the exponents. So 9 minus 3 is 6. So you'd have negative 7 to the 6th power. And this one is also acceptable. On number 14, we have a 2 to the 6th over 2 to the 4th. 2 to the 6th over 2 to the 4th. And so we have 6 2's on the top. So one way to think of it is you got 6 on the top, 4 on the bottom. How many sets would you be able to cancel? Well, you'd be able to cancel 4 sets, leaving you with 2 in the numerator. And so your answer here is 2 to the 2nd, or 4. And just to give you a visual, 2 times 2 times 2 times 2 times 2 times 2, there's 6. And on the bottom we've got 2 times 2 times 2 times 2, meaning that we could cancel out 4 sets, leaving 2 to the 2nd in the numerator. So you could have 2 to the 2nd over 1, or just 4. And that's how I'd answer number 14. Number 15 is telling us to be careful, and what you'll see here is that you've got 6 in the top, 8 in the bottom, and you'd be able to cancel how many sets? You'd be left with, canceling 6 sets, you'd be left with 5 to the second in the denominator. So this would be acceptable. If you did the rule where we subtract the exponents, this would become 5 to the 6 minus 8, which would give you 5 to the negative second power. Then if we use the rule that we talked about earlier, that a to the negative n is equal to 1 over a to the positive n, then you could change this into 1 over 5 to the second. So there's 2 ways to think of this problem, and we end with the same answer. This starts our next section on scientific notation. The first thing is to tell whether the number is written in scientific notation. And I would identify the first part. And one of the rules that we learned is that this first part has to be in between 1 and 10. And looking at it, 0.3 is less than 1. And so this is not in scientific notation. I'll do SN. Number 2, looking at this first part, is this in between 1 and 10? And the answer is no, it's not. And so this is also not in scientific notation. Now let's look at number 3. Write the number in standard form. So to write this number in standard form, I first start by rewriting it, or just copying again, as 2.7. Now I'm going to look at the decimal. And because this is negative, I'm going to make this number smaller. To make this number smaller, I would have to move it to the left. And you can check your foldables on which way you need to move this. But I'm going to be moving this 2 places to the left. So here's my 2.7. 2 places to the left, I'm going to have to add some zeros. 1, 2. And so I get 0.027. And oh yeah, don't forget that this is a negative number. Looking at number 4, I start with 4, and the decimal point would be right here. Which way am I going to move this? Well, it's going to tell me that I need to hop 6 places, and in this case, because it's a positive number, it's going to be a big number. I'm going to hop to the right. So I'm going to add some zeros. Now I just have to move the decimal 6 places. 1, 2, 3, 4, 5, 6. And I'll need to put a comma in every 3. So I get 4, comma, 0, 0, 0, comma, 0, 0, 0. 4 million would be my answer. Number 5, write the number in scientific notation. So what I want to do first is figure out where I would put the decimal so that the value would be in between 1 and 3. And so in this case, it's going to go right there. 3.1 times 10 to the, now I just have to figure out how many places I'm moving it. 1, 2, 3. I moved it 3 places. This is an extremely small number, so I need to make sure that my exponent is negative. 3.1 times 10 to the negative third. On number 6, I need to identify where I'm going to put that decimal so the value is in between 1 and 10. If I placed it here, it would be less than 1. If I placed it here, it would be 7.4, which is in between 1 and 10. So I know I'm going to have 7.41 times 10 to the, now my decimal point currently sits there. I'm going to see how many hops to get it right here, in between the 7 and the 4. 1, 2, 3, 4, 5. 5 hops. And because this is a very large number, I need to make sure that my exponent is positive. On number 9, it's asking us to add these scientific notations. However, there's something that jumps out at me about this problem. In this problem, I have a 10 to the third and I have a 10 to the second. On all your homework so far that we've done this, these are exactly the same, and in this case, it's not. So one thing that we can do is we can make them so that they have the same. So we could either change them to 10 to the third or 10 to the second. And let's talk about this for a second, how we can change this. We talked about in our lesson when we had 4.1 times 10 to the third, if this number here got smaller, meaning we took this decimal and we moved it here, it would make this exponent 1 larger. So let's do the opposite. Let's take this decimal point and move it 1 position this way, meaning that it got larger, meaning that our power would get smaller. So now I have 41 times 10 to the second plus 3.7 times 10 to the second. That being said, now what we're going to do is we're going to add our numbers that are in the front. So 41 plus 3.7 would give me 44.7 times 10 to the, and remember that when these are the same in addition or subtraction, it acts as a label. So it's just going to be 10 to the second. So our answer for number 9 is 44.7 times 10 to the second. But wait a second. Is 44.7 in scientific notation? And the answer is no, it's not. We're going to have to move this decimal so that it's in between 1 and 10. And to do that, we would make 44.7 into 4.47. Making this number smaller would mean that we would have to make our exponent 1 larger. So my answer would be 4.47 times 10 to the third. Looking at number 10, we run into the same issue. This and this are not the same. So we're going to have to modify it. Now let's just think about this. If we make this, move this over to the left and make it smaller, this number would have to get 1 larger, which would be -2. So what I want to do is I want to actually move this number back. That would give me 93. That means that I made this number bigger. My exponent would have to get 1 smaller. So this would give me 10 to the -4th, which is a more negative number. I still am going to have my parentheses. It's still going to be subtraction. 6.9 times 10 to the -4th is still going to be there. So now that we have the same 10 to the -4th power on both sides, now we can look at our numbers. And we have 93 minus 6.9. And I'm just going to do that longhand here. 93.0 minus 6.9. I'm going to have to borrow. That's going to give me 1. That would become 8. And 12. That would become 6. 86. And I drop that decimal point straight down. I get 86.1. And because we're adding or subtracting, this 10 to the -4th power stays the same. So I would get 86.1 times 10 to the -4th. But is this in scientific notation? And the answer is no, it's not. So to make this scientific notation, we're going to have to move this decimal, giving me 8.61 times 10 to the, now look here, we made this smaller, which means this exponent has to get one larger. And one larger, or one more positive, would be -3. So my final answer for number 10 is 8.61 times 10 to the -3rd. Here are the last two questions on the review. In multiplication, so identifying that this is not addition or subtraction anymore, we're simply going to multiply these two front numbers. So I have 1.2 times 4. 4 times 2 is 8. 4 times 1 is 4. And then I have to move the decimal point 1 over. That means this is going to come over. I'm going to get 4.8 times 10 to the, and remember, when we're multiplying these two numbers, we just simply add the exponents. So this would be 10 to the -3 plus 5. -3 plus 5 is 2. So I get 4.8 times 10 to the second. Is this in scientific notation? And the answer is yes, it is. Number 12, we're going to do the same thing. Here I have 7.9 times 4.2. So I'm going to just multiply these two front numbers. I would get 2 times 9 is 18. 2 times 7 is 14, plus 1 is 15. Put in a placeholder. 4 times 9 is 36. 4 times 7 is 28. Plus 3 is 31. Add these together. I get 33. And now remember, I had to move one decimal there, one decimal there. That means I'm going to move it over 2 from the left. I get 33.18. 33.18. Now I'm looking at my powers of 10. So 10 to the 5th times 10 to the 3rd would be 10 to the 5 plus 3, which would be 10 to the 8th. So I have 33.18 times 10 to the 8th. Now my question is this in scientific notation? And the correct answer is no, it's not. But what we can do is we can move this over so our value is in between 1 and 10. That would give me 3.318 times 10 to the... Now remember, if we make this smaller, which we did, our exponent has to be 1 bigger. So this would be 10 to the 9th. Is this in scientific notation? And the answer is yes. This concludes the review for the Unit 10 test. Good luck.